Hello and good morning to everyone. So our today's lead code question is 693, that is binary numbers with alternating bits. So in this question we are given a positive integer and we have to check whether it has alternating bits or not, and if two adjacent bits will always have different values or not. Suppose here we are given 5, so 5 is represented as 101. So if you'll see the adjacent bits, they are different. These two adjacent bits, they are also different. So the answer is true. Right. Now if you'll see 7, 7 is represented as all ones, right? So if you see these two bits are same, then false. Then if you'll see 11, 11 is represented as 1011. So these two bits are uh, adjacent and they are same. Then it is also false. So we just have to check whether all the adjacent bits are different or not. Right. So and next is like, let's see the constraints. So if you'll see the constraints, the number can be up to 2 to the power 31 minus 1. Right. So let's see the approach. So what we do is we'll be start checking each bit and store our previous bit. If previous bit is equal to current bit, if previous bit is equal to the current bit, that means the adjacent bits are same. In that case what we'll do is we'll return false at that point only. We won't be checking future bits, we will be returning false at that point, right? And if we have checked all the bits and this condition is not satisfied, means we haven't returned false at any point, that means all the adjacent bits are different. In that case we will be returning true, right? So how can we check adjacent bits? So if you know, if we take any number n and do AND with 1, it will tell us whether the first bit is either 1 or 0. So if n and 1 is 1, that means the first bit, the lowest significant bit of that number n is 1. If an and 1 is 0, means it is 0. So what we will do is we will take a variable t and store the first bit, right? The first bit, and then what we do is we right shift our number. Suppose we have the number as 5101. So first of all we take this bit, this is n in binary form 101. So if we do n and 1, so 1 and 1 it will give us 1, so t becomes 1. Then we right shift n. So what we do is now our n in binary will become 1 and 10. So what we are doing is we are using a loop until n is greater than 0. Then again we are doing n and 1, right? So if again we do n and 1, so 1 and 0 is 0, 0. But in t, what was our previous t? So t was 1. So if we check whether it is equal to t or not, so it is not equal to this t, right? That means we don't have to return false. Both the adjacent bits are different, right? Then again we right shift with one bit. So what we get now? Now we get 1. Okay. So what we do is 1 and 1 is 1, right? So now our t is equal to 0. So these two are also not equal. So again this condition is not satisfied. So this condition is not satisfied, means these two are also different. So in the while loop this statement is never executed, so at the end we'll be returning false flag, that is true, right? We'll be returning true. So the one point that I want to highlight is this statement. I have written n and 1 equal t. So I have put this in a bracket because the precedence of is equal to is higher than and. So if we'll write n and 1 equal t, so it will be considered as n and 1 equal t. So make sure to use these brackets over here. So I hope I am able to explain you the whole process. So if you like the solution, please make sure to like, share and subscribe the channel. Thank you.